Hello class and welcome to Unit 11 Video 3. Today we're going to go ahead and look at arithmetic series. We just got done looking at arithmetic sequences and geometric sequences. Now we are moving on to series. Okay, so what a series is you take a sequence and you start adding all the terms together and see what number all of them add together. Okay, so your learning target is that you can find the sum, which is addition, of arithmetic series, and you can use sigma notation. Sigma notation looks like this. So you got a big E, and it means to sum the numbers, okay? So we have an example. Suppose a section of an amphitheater can seat 18 people in the first row, and each row can seat 4 more people than the previous row, okay? Well, this is an arithmetic sequence if we write it out, but if we want to know how many people can fit in the first 5 rows, you'd have to tally all of them together. Okay, so in our first row, we would have 18. In our second row, we would have 18 plus 4, so 22. In our third row, we'd have 22 plus 4, so 26. In our fourth row, we would have 26 plus 4 is 30. And lastly, in our fifth row, we would have 30 plus 4, so 34. 34. All right, so what we want to know is find the number of people who can sit in the first 5 rows. Well, this would be a sequence. If I just went ahead and wrote the numbers out, 18, 22, 26, 30, and 34. Okay, a series is when you take those numbers and add them together. So 18 plus 22 plus 26 plus 30 plus 34. So that's the difference. Sequence is just listing the pattern. A series is actually adding them together. If you add all of these numbers together, you will get it's 130 people. All right, so let's go ahead and look at the equation to find an arithmetic series. Okay, the sum S sub n of the first n terms of an arithmetic series is given by, we have 2 equations here. So n is the number of terms. Remember, a sub 1 is the first term. That's why this first term. And remember, d is the common difference. So whatever number you add or subtract every time. Same thing here, a sub 1, this is your first term. And a sub n is actually your last term in your series. So we have 2 equations here. Each of them use a little bit something different. This one uses the difference, this one uses the last term. So it just depends on what you have available to you in order to solve the problem. Okay, I will tell you you're going to need to know these 2 formulas for your upcoming quiz. Okay, so let's look at example 1. The sum of the first 100 positive integers. So what that is saying is we want 1 plus 2 plus 3 plus 4 plus all the way up to 100. Okay, in this case, I know my common difference would be plus 1, but I also know my first and my last term. So the easier part to do is to use this formula. See how it's less complicated? So let's go ahead and do that. We're doing S sub the first 100 integers. So the number of numbers is 100 over 2. Then my first term is 1 plus my last term is 100. So what this tells me is I have 50 times 101. 50 times 101 is 5,050. So if I take those numbers and add them together, the first 100 would add up to 5,050. All right, example 2. Aiden did push-ups every day in March. He started on March 1st and increased the number of push-ups done each day by 1. Okay, if we increase by 1 each day, that means my difference, I'm adding 1. So my common difference is 1. Maybe I'll start a little tally over here. I know that the difference is 1. He did a total of 1,085 push-ups for the month. How many push-ups did Aiden do on March 1st? Okay, so we do not know how many he started doing. That's what we need to figure out. We do know that the sum is equal to 1,085. Okay, and what is n in March? How many days are in March? There are 31 days in March. If you don't know, you can pull out your calendar and look. March has 31 days, so n is equal to 31. So I have my difference, I have my sum. So which of these formulas do I need to use? This one. Okay, so we have S sub n. We do not know how many days it is. So it's n over 2. Then it is 2 times my first term. Do we know the first term? No, we do not. Plus n minus 1. Oh, n minus 1 is 31. 31 minus 1. So I made a silly mistake here. N is 31. It's the number of days we're doing it for. Times the difference, which is 1. All right, so we have to simplify. 31 divided by 2 is 15.5. Then I would have 2a sub 1 plus, this is 30 times 1, so plus 30. And what is my S sub n? It is 1,085. So I need to solve this equation. Let's go ahead and distribute the 15.5. So 15.5 times 2 is going to give me 31a sub 1. And 30 times 15.5 gives you 465. Then in order to subtract, I would subtract 465. 1,085 minus 465 gives you 620 is equal to 31a sub 1. Divide by 31. 620 divided by 31 gives you 20 is equal to a sub 1. So that means on the first day, he did 20 push-ups? Yes. All right, so that is example 2. Example 3, a radio station is giving away a total of $124,000 in August, okay? If they increase the amount given away each day by 100, how much should they give away on the first day? So that's a sub 1. All right, so I know the total, so that's my S sub n is 124,000. I know it is increasing by $100 every day, so it's 100. What else do I know? They are doing it in August. So we have to figure out August. So if you pull up your calendar for August, in August there are 31 days. Okay, so let's go ahead and plug in what we know. We're trying to figure out a sub 1. All right, so which of these should I use? I have D and N. I do not have my last term, so I'm going to have to use this equation again. Let's plug everything in. S sub n is 124,000 equals N, 31, divided by 2, times 2 times a sub 1, plus N, so 31 minus 1 times our difference, 100. All right, so simplifying. 124,000 equals 15.5 times 2a sub 1 plus, this is 30. 30 times 100 will give you 30,000 or 3,000. Let's go ahead and distribute that 15.5 again. $15.5 times 3,000 gives you 46,500. Subtract 46,500 from both sides. And you are left with 77,500 equals 31a sub 1. Divide by 31. And a sub 1 is equal to $2,500. Okay, so on the first day, the radio station should give away $2,500. All right, that is example 3. Do you have any questions about those problems? Now's a good time maybe to pause, take a break, relook them over. If you can, come and ask me a question. Otherwise, write it down for later. Example 4 says find the sum of all positive odd integers less than 180. All right, less than 180. So what we need to do is see what do we know. Okay, less than 180. So positive, so that means we're starting with 1, 3, 5, 7, all the way up to 179. Okay, so those are the numbers we are working with. So in order to figure out how many numbers that is, okay, we are going to actually probably have to use our old equation, okay, which is, what would my a sub 0 term be? -1. Okay, and my D is equal to, I'm going up by 2's. So remember A sub 0 equals mx plus b, where m is your difference, and then that's our A sub 0. Or sorry, this is A sub n. So we're trying to figure out how many numbers we have. And the reason I need to figure that out is because I either need n or I need n no matter what, I guess. So I need to figure out what n is in both equations. So I'm trying to figure out what n is. And I know that my last term, okay, because this is using our equation for a sequence, is 179. So I would add 1, so I'd have 180 equals 2n and divide by 2. So what this tells me is there's 90 terms in this sequence. Okay, so using that, if we ever need to solve for n, you can go back and use your equation for a sequence. So n is equal to 90. D, what does D equal? We're going up by 2 every time. And I think I know my A sub n this time. What is my last term? 179. And my first term is 1. So I can actually use the shorter equation. So we know S sub n is equal to the number of numbers, 90 over 2. Then my first term, 1, plus my last term, 179. So I would get 45 times 180. 45 times 180 is 8,100. So the sum of those 90 numbers is 8,100. Okay, that is example 4. So I just want to recap. The reason I used the equation for an arithmetic sequence was to figure out n. Because if you notice, you need to know n. Maybe some of you could have said, well, we have 180 numbers and half of that is 90 to know what n was. But if you wanted to double check, or some problems won't be as straightforward, you might need to use your arithmetic sequence formula. Okay, 5. Find the first 3 terms of an arithmetic sequence if A sub 1 is negative 16, A sub n is 33, and S sub n is 68. Okay, so I have A sub 1, I have A sub n, and I have S sub n. So this one has the most information provided, so I'm going to use that one. So I'm going to figure out, what am I finding? I'm finding out what n is. Okay, so let's figure out what n is. So we would have 68 equals n, we don't know, over 2, and then I would have negative 16 plus 33. So I have 68 equals n over 2, and then negative 16 plus 33 is 17. 17 divided by 2, 8.5n, so I would divide by 8.5, so n is equal to 8. Okay, so I know that there's 8 terms in my sequence. Now what you need to do is figure out what the difference is. Well, now that I know n, could I use this equation to figure out the difference? Yes. So maybe you would want to make a note. We use this one. Now we're going to use S sub n is equal to n over 2 to figure out our difference. And then from there, we can figure out the first 3 terms. So this is a very involved problem. Okay, so let's fill in what we know. S sub n is still 68. We just found n, it's 8 over 2, times 2 times my first term, negative 16, plus n minus 1, so 8 minus 1, times our difference, which we don't know. So that's what we're trying to find this time. So we have 68 equals 4 times, this is going to be negative 32 plus 7d. Okay, so what I could do is go ahead and distribute the 4. So I have 68 is equal to negative 128 plus 28d. Then I'm going to add the 128 to the other side. 196 equals 28d. If I divide by 28, I get that d is equal to 7. So that is my difference. Okay, it says find the first 3 terms of an arithmetic sequence. So first 3 terms, well, a sub 1 we know, negative 16. A sub 2, my difference is 7, so I would add 7, which gives me negative 9. A sub 3, add 7, negative 2. All right, so that one was a little tricky. So had to do a lot of steps in order to get my answer. So if you have any questions on this problem, please let me know. Otherwise, we're going to go ahead and move on to sigma notation, okay? What this means is you are going to take and plug in the numbers 1 all the way up to 10. So you plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Figure out what you get and then add all of those numbers up. Okay, so when you plug in the bottom number at the bottom, this is your first term, which is your a sub 1 on your equation. When you plug in 10 or whatever this is your last term. Okay, so a sub 10 equals your last term. Then you could also figure out the number of numbers. It's how many numbers is it from 1 to 10? There are 10 numbers. Okay, so we will be using this equation. So from 1 to 10, there's 10 numbers. My a sub 1, okay, I take and I plug 1 in. Whatever numbers listed at the bottom is what I plug in. So 3 times 1 gives me 3. A sub 2, or sorry, not a sub 2. The top number will be my a sub n. So a sub n is equal to a sub 10 in this case. So 3 times 10, so 30. And now to figure out the sum, I would go S sub 10 is equal to 10 over 2, and then it'd be 3 plus 30. So 5 times 33, which is 165. All right, that would be my sum, okay? Maybe you forget the equation on the quiz, okay? But I know if I plug in 1, I get out 3. Plus 2, 3 times 2 is 6, plus 4, sorry, this is term a sub 1, this is a sub 2. So when I plug in 3, 3 times 3 is 9, plus a sub 4 is 12, plus a sub 5, plug in 5, 3 times 5 is 15. A sub 6 is 18, a sub 7 is 21, plus a sub 8 will be 24, plus a sub 9 is 27, plus a sub 10 is 30. So if I take and add all these up, I will get 165. Okay, so either way, sometimes it's harder to do this if it went up to like 1 to 100, you wouldn't want to. But if you get in a situation where you need to on your quiz, go ahead, figure them all out and add them together. All right, this one. Okay, so in this case, my first term is when I plug in 5. Okay, so my a sub 1 term is whatever I plug in the bottom number. So a sub 5 will equal 3 times 5 minus 1, so 15 minus 1 is 14. My a sub n term is when I plug in my top number, so a sub 8, equals 3 times 8 minus 1. That's going to go ahead and give me 23. Now all I need is my n. Okay, here's where it's tricky. You can count it out, okay? It is 5, 6, 7, and 8. So how many numbers is that? 4 numbers. Or you can do 8 minus the number. So 8 minus 5 is 3, but then you need to go ahead and add on 1. This is 3. 3 plus 1 is 4. Okay, so you always have to tack on 1. So if you don't start at 1, you would have to subtract them and then add on 1. So for instance, if I was going to sum from 7 to 56, okay, I would take 56 minus 7 and then tack on 1. So I would have 56 minus 7 is 49. 49 plus 1 is 50. So there's 50 numbers in between here. So that's what n would equal for this example. Okay, so now I can go ahead for example 7 and plug them in. So S sub 4 is equal to 4 over 2. My first term is 14 plus 23. So I would have 2 times what's 14 plus 23? 37, which gives me 74. That is my answer. So this is equal to 74. Once again, let's say I totally forgot the equation. I want to get this right on my quiz. Plug in 5. You would get out 14. We already did that. Then we plug in 6. 18, so this is 17. A sub 7. 21. 21 minus 1 is 20. And a sub 8. We already did 23, but 24 minus 1. 23. So if I take 14 plus 23 plus 17 plus 23, I think I said 23 twice. 14 plus 17 plus 20 plus 23, my sum from j equals 5 to 8 will give me an answer of 74 still. They will match out if you add all of those numbers up. All right, that is the end of Unit 11, Video 3. If you have any questions, please let me know, and just let you know you will need to know these two equations for your quiz at the end of this unit. All right, otherwise have a great day, and I'll talk to you later.